Good morning, Algebra 2. We are going to continue on to the next lesson. This will be titled Algebra 2 8.6, and now we are solving rational equations. So previous to this, we were simplifying expressions. Now we are solving equations. So if we had A over B is equal to C over D, I wanted to get rid of both of my fractions. I could multiply both sides by D, and then I could multiply both sides by B, or I can do a shortcut, cross multiply. So C times B and A times D. So I would end up with A D is equal to C B. Now, this is for different variables, so it's not simplifying it anyway, or I'm not able to solve and get any of them, or learn what any of them equal to. But that's okay, it's just the first example. So using some numbers and things that we're familiar with, we have 3 over x plus 1, and this is equal to 9 over 4x plus 5. Now, since this is just a fraction equal to a fraction, we can use cross multiplication. Now again, what this does is it gets rid of our fractions. That's going to be your first step on any of these problems. Get rid of your fractions in some way. Might be your second step because there will be one step before that, but that should be a majority of them. So here I am going to again cross multiply. So it's 9 times the quantity x plus 1, and that's equal to 3 times the quantity 4x plus 5. So then we'll distribute in both cases. 9 distributing here will become 9x plus 9. Distributing here will become 12x plus 15. Solving for x, pretty simple now. Move 9x to the other side, subtract 9x from both sides. Going to end up with 9 equals 3x plus 15. Subtract 15 from both sides. So negative 6 equals 3x. Divide both sides by 3. You end up with a negative 2. Negative 2 equals x. So you'll notice the difference between this lesson and the previous ones is that we do have equals signs throughout the entire problem and the beginning, which means that our final answer needs an equals sign. So we need to solve for whatever the variable might be. In the previous cases where we just had simplifying expressions, we would not be solving because there was no equal sign present. Let's try another one. Let's say we are given example B, which is 5 over x plus 7 over 4, and this is equal to negative 9 over x. Now, this one there's a couple more things going on. If I was thinking of some order of operations, I should do the left side first. I could add them together. Finding a common denominator, adding them together, and then I would have one thing on the left side, which would be a fraction numerator and denominator, equal to one thing on the right side, a numerator and denominator, and then I could cross multiply like I just did. But there's actually an easier way. What we can do is we can find the LCD of all denominators. Find the LCD of all denominators. So if I'm taking a look here, x would be a part of that LCD. 4 would be a part of that LCD, and the second x is actually already taken care of or accounted for. So my LCD in this case would just be 4x. And so now what I'm going to do is I am going to multiply both sides of the equation. So both sides, so if I have 5 over x plus 7 over 4 is equal to negative 9 over x. And since it's an equation, I can multiply both sides by just one thing rather than multiplying them by 1. Remember, when we're trying to get common denominators, we're just multiplying fractions by 1 technically. You're multiplying by x over x or 4x over 4x. In this case, I can just multiply both sides by 4x, and I'm actually going to split this up into both two different pieces. So starting with the right side, this 4x is multiplying to negative 9 over x, and so 4x is really over 1. And so I also already can see that I can do something else. It's called cross-canceling. So those two x's can cancel out. So I'll end up with negative 9 times 4, which is negative 36. On the left side, I need to be sure to distribute to both things. Okay, so really this is going to become 4x over 1 times 5 over x plus 4x over 1 times 7 over 4. And so again, I can do some canceling. Over here on the left, the first one, the x's will cancel. So I'll just have 4 times 5, which is going to be 20, plus on the next problem, I have the x's cancel. Sorry, the 4's cancel this time. So it's just 7 times x, and so I'll have 7x equals negative 36. Solving for x, you just have one x variable. You want to get it all by itself. So I'm going to subtract 20 from both sides. 7x equals negative 56. Divide both sides by 7, and x equals negative 8. Something I do want to mention, as this is an equation and you're solving for a variable, anytime you do that, you can always plug it back in and check. So I could plug negative 8 back into x in my very original problem, and both sides will be equal. Both sides would end up being negative 9 over negative 8, or 9 over 8 equals 9 over 8. You can pause the video and try that if you like. Let's try another problem. We have here example C. 1 minus 8 over x minus 5 equals 3 over x. That's actually all, okay? And now we want to find the LCD, the least common denominator of everything, okay? So I have, for my LCD, I have an x, but this x does not account for the other x because remember, it is a separate factor. So this is x minus 5 and this is x. They are separate factors. And so my LCD can be x and it can be x minus 5. Well, it has to be. The 1, on the other hand, is just 1 over 1. And so you can include a 1 here, but you don't need to. It's not going to change the problem. It's an invisible 1. So I need to take this and I need to multiply both sides of my equation by the LCD. X times the quantity x minus 5 times 1 minus 8 over x minus 5 equals 3 over x times x minus 5. So be careful again, because on the right side, these x's automatically cancel, and that's fine. I would just be left with 3 times the quantity x minus 5. On the right side, however, you need to remember that you're distributing to both things. So the x minus 5 and the x minus 5 don't automatically cancel, because I first need to take this times 1, and so 1 times whatever this is just going to be itself. Then I'm distributing that to multiply it here. So I'm going to rewrite it real quick. So multiply that times 1 minus, and I'm distributing actually, yeah, minus x minus 5 times 8 over x minus 5. So again, here in this case, the x minus 5 and the x minus 5 cancel. On the right side, left side, I have x times x minus 5 minus, and 8 times x is 8x. Bring this side down. Got rid of all of my fractions. So now I can distribute and solve for x. Starting on the far left side, x times x is x squared minus 5x minus 8x, that just comes down, equals, again, distributing over here, 3x minus 15. Now, I have an x squared, and I have an x in my problem, which means I can't combine those at any time. So that means that I need to move everything to one side, and I will need to factor. So let's go ahead and subtract 3x and add 15 to both sides. Be careful, it may have been more helpful to combine these two things first. Let's just go ahead and do that. Negative 5 minus 8. Negative 5x minus 8x is going to be a negative 13x. So now on the left side, I have an x squared minus 16x plus 15. And this all equals 0. So see where we have come from. We came from having multiple fractions to no fractions, okay? We have an x squared term, which gives you the hint that you're going to have to factor. So now we need to factor. So I'm going to take the first thing, which in this case is 1 times 15. So that's 1 times 15 is 15. And that's going to be factors of 15 that have to be a negative 16. That's going to be negative 15 and negative 1. Again, negative 15 times negative 1 is positive 15. Negative 15 minus 1 is negative 16. So now, since this was a 1, I can use my shortcut. Only when that is a positive 1. So this is x minus 15 times x minus 1 equals 0. I know it's been a while, but now you're going to set each of these factors equal to 0. Here's one factor, there's another factor. So x minus 15 equal to 0, x minus 1 equal to 0, therefore x equals positive 15 and x equals 1. Now, I don't believe exactly what the instructions say, but I don't think it's said to check for extraneous solutions. If it does, remember that's when you have extra solutions. If it does say check for extraneous solutions, I will need to plug both of these back into my original and see if they both end up being true. If they're both true, then they are both answers. If only one is true, that's the only answer. And if neither happens to be true, then I actually have no real answers for this problem.